So this is topic 7.3. It's all about adding fractions that don't have the same denominator, unlike denominators. You're going to need your pencil and your notes. And our objective, our goal, is that you are able to add and subtract fractions that don't have the same denominator. So you need to write topic 7.3, use the Roman numeral number 3, write unlike denominators. And our first step to add or subtract fractions is they have to have the same denominator. Now why is that? Why can't I just add 1/2 and 1/3? Well, I'm going to show you here. If we had 1/2, when you add 1/3, if we put pieces together that to make it the same size, if I just took 2 1/2s, it'd be too big. Or I took 1/3, it'd be too big. So we had to find smaller pieces that would fit. This is just like the tiles that I showed you in class. So if we took all the little 1/6, it takes 5 1/6 to equal the same size as the 1/2 and 1/3. And that's why they need to have the same denominator, okay? So how do we do that? Well, first we need to change the fractions so they have the same denominator, or the LCD, their least common denominator. So here's my example, 5 12ths plus 3 10ths. The 12 and the 10 are not the same number. We need to make them be the same number. We're going to do that by doing our LCD. If you know what the least common denominator is, if you just know that it's 60, great. If you don't know, you should use the birthday cake method that we learned before. And I'll show you again. So you take your denominators, 12 and 10, put them in our layer, 12 and 10. A number that can go into both 12 and 10 is 2. 2 goes into 12 6 times, and 2 goes into 10 5 times. There's nothing that goes into 6 and 5. So now we multiply all the numbers. 2 times 6 is 12, and 12 times 5 is 60. So their LCD, or their least common denominator, is 60. I'm going to erase this. So once I've made it so that they have a new denominator, 60 and 60, so this old denominator is gone. But I'm not allowed to just change part of a fraction because I feel like it. I have to use the laws of equality, and since I changed the 12 to a 60, I need to change the numerator also. I have to be fair. I multiplied the 12 by 5 to make it a 60, and so since I multiplied the bottom by 5, I also have to multiply the top by 5. Now look at that, I'm multiplying it by 5/5, or 5 divided by 5. How much is 5 divided by 5? Oh, it's really, remember, it's just a 1. So I'm really multiplying it by at a 1, okay? And you're allowed to do that because of the laws of identity that we talked about before. So 5 times 12 is 60, and 5 times 5 is 25. Now we multiplied our 10 by 6 to get 60, and since I multiplied the bottom by 6, I have to be fair, laws of equality, and multiply the top by 6. And what is 6 over 6? It's really just a 1, so you're allowed to do that. 10 times 6 is 60, and 3 times 6 is 18. So I changed the denominator. We used our birthday cake method to find out our least common denominator. I made the numerator equivalent by multiplying the top and the bottom. And now I'm going to add the numerators and rewrite the denominator and simplify. So I'm going to add 25 and 18. So 25 and 18 is going to be 43 over 60. We don't add the denominators together. We only add our numerators. You should simplify if you can. We're going to try it again right here. 4 7ths minus 1/5. I need to first make it so they have the same denominator. What is their common denominator? What's the number that both 7 and 5 can turn into? 35. What did I multiply this 7 by to turn it into a 35? I multiplied it by 5. Since I multiplied the bottom by 5, I need to multiply the top by 5. And we're allowed to do that because 5/5 is really just a 1. 5 times 4 is 20. So this fraction's been changed. It's gone now. I'm going to subtract it. What did we multiply our 5 by to get 35? We multiplied it by 7. And since I multiplied the denominator by 7, I have to multiply the numerator by 7 to keep it even. 7 7ths is just a 1. 1 times 7 is 7. So this fraction is gone. They've become equivalent now. I'm not equivalent, excuse me. They've had the same denominator. Now we're just going to add or subtract our numerator. 20 minus 7 is 13. And we were going to rewrite our denominator, 35. Now sometimes this is still confusing, so I'm going to teach you a trick. This is not real math. This is funky math. It's called the box method, but it will work for those of you who are feeling insecure about adding and subtracting fractions with unlike denominators. So let's say we have the fractions 3/8 plus 2/12, okay? Let's do our original way, so you can see the magic of the box method. Their least common denominator is going to be 24. So 24 and 24. I multiplied that by a 3 and that by a 3. I multiplied this by 2 and that by 2. When we add them together, we're going to get 13/24. I'm going to show you how to get that same answer with our original problem right here, using the box method. So what you're going to do is you're going to draw this box like this. You draw a line here, and a line here, and another line here, and another line here. And we'll do this in class a couple times as well. The first thing you're going to do, number one, is going to write the fraction. So I have 3/8 and 2/12. I'm going to write 3/8 and 2/12. Your next step is you're going to multiply. 8 times 2 is 16. I'm going to write the answer right here. 12 times 3 is 36. I'm going to write that answer right here. Your third step is you're going to add the top numbers. 36 plus 16. 36 plus 16. I just confused myself. You get a 42. 52. And then you're going to multiply the bottom two numbers. 8 times 12 is 96. So I got 52 over 96. But when I reduce it, it becomes 13/24, the same answer. Okay guys, so we'll go over this box method again in class tomorrow. Okay.